In the winter of 1945, a German test pilot climbed into a cockpit that no sane man should have entered. The aircraft beneath him was unstable, underpowered, and held together by a program running on desperation rather than engineering confidence. What happened next would mark the final collapse of the Luftwaffe's most ambitious gamble. A rocket-powered interceptor that was supposed to stop the Allied bombing campaign dead in its tracks. It didn't. And the cost of that failure wasn't just a prototype. It was Germany's last real chance to control its own skies. By 1944, Germany was losing the air war not slowly, catastrophically. The 8th Air Force was sending 1,000 bombers at a time over German cities. And the Luftwaffe, once the most feared air power in the world, was bleeding out. Experienced pilots were dying faster than they could be replaced. Fuel was becoming scarce. Conventional fighter production couldn't keep pace with Allied manufacturing on an industrial scale. Berlin knew this. The RLM, the Reich Air Ministry, knew this. And in that desperation, they turned to rocket propulsion, not jet engines. Rockets. The logic was brutal in its simplicity. A rocket-powered aircraft could climb to bomber altitude in minutes, attack, and land. No need for long fuel reserves. No need to engage enemy fighters in sustained combat. Just a vertical strike. Fast and lethal, before the escort fighters could respond. The aircraft chosen to deliver that strategy was the Messerschmitt Me-163 Comet, and the story of how it rose, failed, and ultimately died on a test field in Germany is one of the most tragic and fascinating episodes of the entire air war. The Me-163 did not begin as a fighter. It began as a research glider. Alexander Lippisch, the Austrian aerodynamicist whose obsession with Thales flying wings bordered on the philosophical, had spent years designing aircraft that defied conventional thinking. His DFS-194 glider was the seed from which the Comet would grow, a swept-wing tailless design that Lippisch believed could achieve speeds no conventional airframe could match. In 1939, Lippisch and his team were transferred to Messerschmitt's facility at Augsburg, an arrangement that was tense from the start. Willy Messerschmitt and Lippisch were not natural collaborators. Their engineering philosophies clashed, their personalities clashed, and the bureaucratic friction between their teams would haunt the program for years. But the aircraft kept evolving regardless. The DFS-194 was fitted with a Walter HWKRI rocket motor and flown in 1940. The results were startling enough that the ROM pushed the project forward into what would become the Me-163, a dedicated rocket-powered interceptor prototype. The airframe was radical. The wingspan was barely 9 meters. There was no conventional undercarriage. The aircraft took off from a wheeled dolly that was jettisoned after liftoff and landed on a central skid. It was designed for speed, not comfort, not safety. Speed above everything else. Heini Dittmer was the man who first pushed that design to its limits. A glider champion and one of Germany's most gifted test pilots. Dittmer flew the Me-163A series through a progression of increasingly dangerous test flights at Peenemünde, the same Baltic coast facility associated with Germany's VOE-PAN programs. On October 2, 1941, Dittmer reached a speed of approximately 1,003 km per hour while being towed to altitude before igniting the rocket motor. That figure, disputed slightly in various sources but consistently cited as around 1,000 km per hour, was beyond anything any pilot had ever experienced. The aircraft began to shake violently as it approached compressibility effects. Dittmer cut the engine and glided down. He had touched the edges of the sound barrier in a propeller-free aircraft at a time when most fighters were still doing 600 km per hour. That flight should have been a triumph. In some ways, it was, but it also revealed something the engineers couldn't ignore. At extreme speeds, the Me-163's handling deteriorated sharply. The swept-wing design that gave it such aerodynamic efficiency at high velocity became unpredictable near compatibility. Control inputs became sluggish. Recovery from unexpected attitudes was not guaranteed. These were not small problems. In a combat aircraft, they were potentially fatal ones. The transition from the Me-163A research aircraft to the Me-163B Comet, the production combat variant, involved significant redesign. The Walter HWK-109-2509A rocket motor that powered the B variant generated around 1,700 kilograms of thrust, burning a volatile combination of two propellants known as T-Stoff and C-Stoff. T-Stoff was highly concentrated hydrogen peroxide. C-Stoff was a methanol-hydrazine mixture. Together, they produced tremendous thrust. They were also extraordinarily dangerous. T-Stoff reacted violently with virtually any organic material, including human tissue. Ground crew worked in specialized protective suits. Fuel spills were not merely messy. They were potentially lethal. Several ground personnel were severely burned during handling accidents throughout the program. The airframe itself was assembled primarily at facilities including Regensburg and later dispersed production sites as Allied bombing intensified. By 1944, the program was under pressure from every direction. The RLM wanted results. Hitler wanted wonder weapons. And Lippisch had already departed the program by 1943. Frustrated by the political and bureaucratic interference that had plagued the project from its earliest days, the detailed engineering work fell to Messerschmitt's team, working under conditions of increasing chaos. Bundeskommandos 16 was the Luftwaffe test unit established to evaluate and operationalize the Me-163B. Based at Bad Zwischenau in northwestern Germany, EK-16 brought together a group of pilots and technical staff tasked with figuring out how to actually fight with an aircraft that had been designed by theorists. The practical problems they encountered were numerous and sobering. Wolfgang Spate, a decorated Luftwaffe fighter pilot and one of the early commanders of EK-16, described the Me-163 as an aircraft that demanded complete respect at every moment of flight. The takeoff run was violent. The rocket ignition pressed pilots back into their seats with force, unlike any piston engine could produce. The jettisoned dolly was, itself, a hazard. If it bounced on the runway, it could strike the fuselage on its way past. The landing approach was one of the most demanding exercises in Luftwaffe aviation. With the rocket motor exhausted and the aircraft gliding at high speed, the pilot had one chance. There was no Guran, no second approach. The skid landing on grass strips was rough, and any crosswind or surface irregularity could send the aircraft veering off course. But the most dangerous moment was not the landing. It was everything in between. The Me-163B's rocket endurance at full thrust was approximately 8 minutes. 8 minutes in which the aircraft would climb, attack, and have to disengage. After that, it was a glider. A very fast glider, but a glider nonetheless. Allied escort fighters learned quickly that patience was a weapon against the Comet. They simply waited at a lower altitude for the rocket motor to exhaust. Then the Me-163, suddenly reduced to a gliding target with no offensive capability, could be pursued and destroyed. Jeswata 400 was the only operational Comet unit, flying combat missions beginning in the summer of 1944. Their operational base at Brandes, near Leipzig, put them within range of American bomber formations, targeting the synthetic fuel plants at Luna and surrounding industrial areas. The pilots of JG-400 flew with genuine courage. They were not flying a reliable machine. They were flying a machine that was simultaneously the fastest aircraft in combat and one of the most accident. The kill-to-loss ratio of the Me-163 in combat tells its own story. Despite the aircraft's astonishing speed, it could approach bombers too fast for effective gunnery, a problem the RLM acknowledged and attempted to address with the Jagdfaust upward-firing rocket. Installation JG-400 achieved a confirmed total of around 9 to 16 Allied aircraft destroyed across its entire combat career, depending on the source. The losses to accidents, mechanical failures, fuel explosions, and combat were disproportionate. Some pilots were killed when their aircraft exploded on landing, residual propellants detonating on impact. Others were killed in crashes during training. The aircraft was consuming its own pilots. There were attempts to address the rocket motor's limitations. The Walter 109-509C motor, a variant with a cruise chamber designed to extend endurance, was developed and tested. The concept was straightforward. Run the main chamber for the attack climb, then switch to the cruise chamber for sustained flight. In practice, the engineering was immensely difficult, and the program never reached meaningful operational deployment before the war ended. By late 1944 and into early 1945, Germany's strategic situation had collapsed beyond any point where the Me-163's performance could alter the outcome. Fuel shortages grounded aircraft across the Luftwaffe. Allied bombing destroyed production facilities. The dispersed underground factories that had been constructed to protect the program were themselves running out of raw materials and skilled labor. Pilots completed training only to find no serviceable aircraft waiting. The final recorded operational sorties of JG-400 occurred in April 1945. By then, the war in Europe had weeks left. Allied ground forces were closing on the Rhine from the west. Soviet forces were driving toward Berlin from the east. The airfields from which JG-400 operated were overrun one by one. Some Comets were found intact by American forces, some destroyed by their own ground crews to prevent capture, others simply abandoned in the chaos of the German collapse. What the Allies found when they examined the Me-163 program in detail was a combination of genuine brilliance and fatal compromise. The aerodynamic design was ahead of its time. Lippisch's instincts about swept-wing tailless aircraft were validated in post-war research, informing designs that would appear years later under different flags. The rocket propulsion system demonstrated capabilities that accelerated Allied understanding of high-speed flight. American and British test pilots who flew captured comets after the war reported the experience as unlike anything in their prior careers, simultaneously impressive and deeply alarming. The fundamental failure of the Me-1063 was not engineering. It was doctrine, timing, and the catastrophic circumstances of the regime that built it. An aircraft designed for a war Germany was still winning could not rescue Germany from a war it had already lost. It required infrastructure that no longer existed. It required fuel that could no longer be produced. It required trained pilots dying faster than they could be graduated. And it required time, a commodity that had run out completely. The Me-163 comet shot across the skies of 1944 like the rocket it was, briefly brilliant, burning intensely, and spent before it could do what it was designed to do. The test pilots who flew it, the engineers who built it under impossible conditions, the ground crews who worked with propellants that could kill them without warning, they were participants in one of aviation history's most genuinely extraordinary experiments. That it ended in failure was not entirely their fault. They were handed a revolution and told to win a war with it. No revolution works that fast. If stories like this, the forgotten programs, the dangerous machines, the real men behind classified aviation history, are the kind of history you want to keep uncovering, then consider subscribing. There are more of these stories, and most of them have never been told the way they deserve.